So this is a continuation of solving systems by substitution, and I didn't include this into the original video. This is just an add-on if you want to know how to apply substitution when both the equations are written in standard form. Traditionally, whenever you're dealing with substitution, you really only want to use it whenever one of the equations is set to one of the variables, set equal to one of the variables. It makes it nice, smooth, and easy. So when you have them both in standard form, yes, you could totally use substitution. It probably wouldn't be the route to go because there is the process of elimination that we are going to learn. But I'm going to go ahead and show you in case you want to know. When you're solving for substitution and they're both in standard form, you want to figure out which equation you could easily solve for one of the variables, and it takes like one step, maybe two. For instance, number 10. If I were to solve the first equation for x or y, it would involve more than one step. But if I look at the second equation, I could easily just subtract 2x and then have y by itself. So y equals negative 2x plus 9. And then it becomes a substitution problem where I'm going to substitute negative 2x plus 9 into the y value of the first equation, which is what we talked about in the previous video. So 2x minus 3 times negative 2x plus 9 equals negative 11. Then I distribute and solve like we practiced. So negative 3 times negative 2 is positive 6x. Negative 3 times positive 9 is negative 27 equals negative 11. Then I'm going to combine like terms and solve. So 2x plus 6x is 8x minus 27 equals negative 11. Then I'm going to add 27. So 8x equals 16. Then I'm going to divide by 8. So x equals positive 2. Where to solve for the y value, I'm going to take that 2 and substitute it back into one of the x's in the original equation. Again, it does not matter which one. If I substitute it in for the first one, I would rewrite 2 times 2 minus 3y equals negative 11. 2 times 2 is 4 minus 3y equals negative 11. I would subtract 4, so negative 3y equals negative 15, where I divide by negative 3, so y equals positive 5. So my coordinate ends up being 2, 5. So taking that into consideration, number 11, which equation do you believe would take less steps for me to solve for one of the variables? And the one in this case would be solving for y in that first equation.
The expert.
Because all you would have to do is subtract 2x to that first equation. So it would be y equals negative 2x minus 2. So then I can substitute negative 2x in for the y in the second equation. So I have 5x plus 3 times negative 2x minus 2 equals negative 8. And then distribute and solve. 3 times negative 2x is negative 6x. 3 times negative 2 is negative 6 equals negative 8. Combine like terms, so 5x minus 6x is negative 1x. Minus 6 equals negative 8. Then I would add 6. And negative 1x equals negative 8 plus 6 is negative 2. Divide by negative 1, so x equals positive 2. Then I would take 2 and substitute it back into the original or one of the originals. If I do the first one, it would be 2 times 2 plus y equals negative 2.
Connor Silva.
And so 2 times 2 is 4 plus y equals negative 2, where I would subtract 4, so y equals negative 6. So my ordered pair for that one would be 2, negative 6. Last but not least, number 12. So which equation do you believe you could easily solve for one of the variables in one step? That would be the first one, and I would solve for x. How I would do that is by subtracting 5y. So x equals negative 5y plus 4, which I know looks odd because we're used to solving for slope-intercept form, but not this time. So we're going to take negative 5y plus 4 and substitute it in for the x in the second equation. We have 3 times negative 5y plus 4 plus 15y equals negative 1. And then I'm going to distribute and solve. So 3 times negative 15y is negative, or times negative 5y is negative 15y. Plus 12 plus 15y equals negative 1. This one's pretty special because when I combine like terms, I have negative 15y plus 15y, and that equals 0, so those cancel. And I'm left with 12 equals negative 1. Since that's not a true statement, this is one of those special cases where you would get no solution. So if that ever happens on a regular substituting problem, just know it's no solution. If it were 12 equals 12, then that would be infinite solution.